Welcome to NEET Direct program by SP Smart. Today we shall discuss the NCERT problems from the chapter of bulk matter, part first. So let us start from example 9.1. A structural steel rod has a radius of 10 millimeter. So I'll write here radius is 10 millimeter, and this means 10 power minus 3 meters, that is 10 power minus 2 meter, right? It is a length of 1 meter, so length is 1 meter. A 100 kilonewton force stretches it, so force applied is 100 kilonewton, which means 10 power 3, and this is 10 power 5 newtons. This is given. Now you have to calculate the stress, right? And as you know, stress is force per unit area. Area here is area of cross section pi r square. Force, as you can see, is 10 power 5 newtons. Pi is 3.14 multiplied by radius square. Radius is 10 power minus 2. So 10 power minus 2 whole square. You simplify it further. When you simplify, you get this equal to 3.18 into 10 power 8 Newton per meter square. So this is the stress that acts on the given structural rod. Now this question, another part. You're supposed to know the elongation also. There is delta L. So in part B, as you know, F by A is equal to Y delta L by L. So here elongation means this delta L. So let's simplify it. Delta L is equal to F by A into L divided by Y. Now you make substitutions here. Okay, we have just calculated this F by A. I put its value. This is F by A, that's the value, right? So I write 3.18 10 power 8 into the length. You can check it out from here. Length is 1 meter, so into 1 divided by Young's modulus, and that happens to be 2 10 power 11, right? So I write here 2 into 10 power 11. You simplify it further. It comes to be 1.59 10 power minus 3 meters, or you can say simply it is 1.59 millimeter. So this is the elongation produced in the structural rod. Now there is third part also to this problem. You are asked to calculate the strain on the rod. That's part C. So let me move on. See, this is F by A and this is delta L by L. Strain simply means this part. So you are supposed to find delta L by L. I think that's quite easy now. Strain is delta L by L. Delta L, I've just computed 1.59 millimeter, or you can say 1.59 10 power minus 3 meters divided by length, which is 1 meter. So it is 1.59 10 power minus 3. All right. So this is the strain, and in this way we have found all the three parameters which were supposed to find in this problem, right? Okay, now let's take up question 9.21 from this chapter. See, a marina trench is located in the Pacific Ocean and at one place in its nearly 11 kilometer beneath the surface of water. The water pressure at the bottom of the trench is about 1.1 10 power 8 pascals, right? So let me write, the pressure is 1.1 10 power 8 pascal. This is at the bottom of the ocean. A small steel ball of volume 0.3, so this is the volume, initial volume 0.32 meter cube, is dropped into the ocean and falls to the bottom of the trench. What is the change in the volume of the ball when it reaches the bottom? See, we know pressure, this bulk modulus, this is a formula, standard formula that we use here, right? Now let's start making the substitutions. P value is 1.1 10 power 8. All right. This is B, the bulk modulus. Bulk modulus of steel, as we know, is 1.6 10 power 11 pascals. Delta V we are supposed to find, and what's the volume? 0.32, as you can see from here. Therefore, delta V is equal to 1.1 10 power 8 divided by 1.6 10 power 11 into 32 by 100. So if I simplify this, and these three parts, I get 22. Now you have this 10 power 8 minus 10 power 13. It is minus 5, and this happens to be this much. So this is the change in volume of the sphere when dropped to the bottom of the Pacific Ocean at Mariana Trench. Okay, now let's move on to question or example 9.4. A square lead slab of side 50 centimeter and thickness 10 centimeter. So these are the two parameters, 50 and 10. So here we see this is 50 mentioned here, okay, and the width is 10, subject to a shearing force on the narrow face, or this I should write here now. It's better I write. Shearing force, shear होता है F by A. How much is it? 10 power 4 divided by area. Area, it has to be 50 into 10. 50 into 10. These are centimeter square. I make it meter square. Right? So it becomes 10 power 4 over there. It is 5, 10 power minus 4 plus 2. That becomes 10 power 4 plus 2 by 5. And this happens to 0.2 into 10 power 6, but there is a little mistake. I should incorporate this 9.0 also. Why? Because the actual value was 9.0 into 10 power 4, so it has to be 9 here, 9 there, 9 there, and of course 9 there. It's now 9 into 0.2 is 1.8 10 power 6 Newton per meter square. So this is the answer to first part of the problem, where you were supposed to find only the stress. Now we move on to the next part. We know stress is equal to bulk modulus, or sorry, shear modulus into strain. In short, this is stress, this is strain, this is bulk modulus. Now start making the substitutions. F by A, we just calculated 1.8 10 power 6. Alright. And here eta, this is bulk modulus. It is given 5.6 into 10 power 9. The 5.6 gigapascal. So eta is there. Delta x we are supposed to find. And what's the length? Length of this edge is given to be 50 centimeter. So I put here 50 centimeter. I make it into meters. Therefore, delta x is given after making all these calculations. Right. So delta x is 1.8 into 10 power 6 into 5 into 10 power minus 2 divided by 5.6 10 power 9. And when you further simplify, it happens to be 0.16 into 10 power minus 3 meter, or you can simply write it as 0.16 millimeters. So this is the elongation produced here. And when I say it's elongation produced, I mean this increase in the width here, over there. So this is what we have just calculated. So in this way, we have solved all these problems from the NCERT book from the chapter of bulk matter under the program NEET Direct by SP Smart. That's all for today. God bless you all.